All right, guys, good morning. So, I wanted to give you all a little bit more information about oxidation reduction reactions or redox reactions. And I know that this topic is a little bit tricky, but as you continue to learn more about it in biology as well as chemistry, I promise that it will start to make sense. So, let's go through a quick review. So, in an oxidation reduction reaction, it's important to remember that electrons are being exchanged. Usually, we have one molecule or atom that is stealing electrons and the other that is losing electrons. So, back when we were talking about cations and anions, remember that cations are positively charged, so they've lost electrons, and anions are negatively charged, so they've gained gained electrons. Our anions are the ones that have stolen electrons from our cations, which have lost them. So that is the basis of an oxidation reduction reaction. Basically, these reactions are explaining how cations and anions are formed when atoms and molecules are stealing electrons from each other. And basically, after they've stolen electrons from each other, sometimes that means that the atoms and molecules rearrange to create new products. So that's what those reactions are showing. So here, just remember that oxidation is loss. So if an atom or a molecule is being oxidized, that means it's losing electrons and it's becoming more positive. So something is stealing its valence electrons. If something in the reaction is reduced, that means it's stealing or gaining electrons, so it's becoming an anion. So again, our acronym here is oil rig. Oxidation is loss of electrons, and reduction is gain. Okay, so what does that mean in real life? When we're looking at these reactions, basically we're going to see one atom or molecule that is losing electrons and one that is gaining electrons. And in our product, we see that stealing or that loss. So here we have copper oxide. We have a cation of copper, so that's copper plus 2, it's a cation, bonded with an oxygen that is negatively charged, minus 2. So we have a compound here, and then we have magnesium. So magnesium here doesn't have any charge, it's just hanging out by itself. But what's going to happen here is that our copper that is positively charged here is going to steal electrons from magnesium. Because copper is positively charged here, that means it has fewer electrons than it wants, so it's going to steal them from magnesium. So as you can see here in the products, copper now doesn't have any charge. It's not a cation anymore because it was missing 2 electrons and it stole those 2 electrons from magnesium. So since magnesium didn't have a charge and now it lost electrons, now we have magnesium minus 2 electrons. So it's a positive cation connected to our negatively charged oxygen. So basically in this oxidation reduction reaction, we had a switch. First, magnesium was by itself. Now copper is by itself. And again, copper is now by itself because it gained 2 electrons from magnesium. So remember, oxidation is loss, reduction is gain. So copper was reduced because it gained 2 electrons from magnesium, And magnesium was oxidized because it lost 2 electrons to copper. Okay, one more example for you guys. And again, don't worry about knowing where the charges come from and how many there are. In chemistry, you guys are going to learn that more, but I want you to just basically see today the exchange of electrons between these different reactants and products. So in this example, we have solid copper hanging out by itself, no charge. And then we have Ag, so that's silver. And we have an Ag ion that's positive. So positive means that it has lost 1 electron. And this here, these show the forms of our reactants. So S means solid, so we have a copper solid, and AQ means aqueous. So this week we're going to start learning about solutions. That basically means that this positive cation is floating around in water. So we have solid copper in liquid water that has silver ions floating around. As you can see on our products, now copper is the one that has a charge and is in water, aqueous. And now silver is a solid. It's no longer floating around in the water. So how did that happen? Remember, oxidation is loss, reduction is gain. So copper is the one that became a cation. So it lost 2 electrons. It lost 2 electrons, so where did they go? Silver was a cation. It was missing electrons, but it actually stole those electrons from copper and took it for itself over here. So here, copper was oxidized because it lost electrons, and silver was reduced because it gained electrons and became a solid. So those are 2 examples. Again, please don't worry about where the exact charges come from. I just want you to see how oxidation shows a loss of electrons, so you're making a cation, and reduction is a gain. So you're either making a complete atom or molecule or creating an anion, depending on the situation.